Grounding a metal switch box requires specific hardware to ensure a safe and effective electrical connection. The central question revolves around whether the clamp screw, without the clamp itself, can be used as a grounding means, or if a dedicated green grounding screw is mandatory. The answer, according to established electrical codes and best practices, is that using the clamp screw without the clamp is not permissible. A green grounding screw must be used. Let's delve into the reasons behind this requirement and the proper methods for grounding metal switch boxes. Firstly, understanding the purpose of grounding is crucial. Grounding provides a low impedance path for fault current to return to the source, typically the electrical panel. This low impedance path facilitates the rapid tripping of a circuit breaker or blowing of a fuse, effectively interrupting the circuit and preventing electrical shock hazards or potential fires. Secondly, the National Electrical Code, or NEC, which is widely adopted in many jurisdictions, sets forth specific requirements for grounding electrical enclosures, including metal switch boxes. The NEC mandates the use of listed and approved grounding methods to ensure the integrity of the grounding system. The clamp screw, without the clamp, is not designed or listed for use as a grounding terminal. Its primary function is to secure cables entering the box, not to provide a reliable electrical connection to ground. Thirdly, a green grounding screw is specifically designed and listed for grounding purposes. These screws are typically made of a conductive material, such as brass or copper, and have a distinct green color for easy identification. They are designed to provide a secure and reliable connection point for the grounding conductor, which is typically a bare copper or green insulated wire. Fourthly, the design and construction of a green grounding screw ensure a low resistance connection to the metal enclosure. The screw threads are designed to bite into the metal of the box, creating a tight mechanical and electrical connection. This connection is essential for effectively carrying fault current back to the source. Fifthly, using the clamp screw without the clamp as a grounding means can introduce several potential problems. Firstly, the connection may not be reliable. The screw may not be tightened adequately, or it may loosen over time due to vibration or thermal expansion and contraction. This can result in a high resistance connection, which can impede the flow of fault current. Secondly, the screw may not be made of a suitable conductive material. If the screw is made of steel or another material with high resistance, it can limit the amount of fault current that can flow through it. This can delay the tripping of a circuit breaker or blowing of a fuse, increasing the risk of electrical shock or fire. Thirdly, the screw may not be properly sized for the grounding conductor. If the screw is too small, it may not be able to accommodate the grounding conductor securely. This can lead to a loose connection or even the complete disconnection of the grounding conductor. Sixthly, proper grounding techniques for metal switch boxes involve several steps. 1. Ensure that the metal switch box is properly bonded to the grounding system. This means connecting the grounding conductor to the green grounding screw in the box. 2. Use a listed and approved grounding connector to connect the grounding conductor to the green grounding screw. 3. Tighten the grounding screw securely to ensure a low resistance connection. 4. If the metal switch box is fed with metallic conduit, ensure that the conduit is properly bonded to the grounding system. This can be achieved by using bonding bushings or other listed and approved bonding methods. 7. The size of the grounding conductor is determined by the size of the circuit conductors feeding the metal switch box. The NEC provides tables that specify the minimum size of the grounding conductor based on the size of the circuit conductors. For example, NEC Table 250.122 provides guidance on equipment grounding conductor sizing. 8. In some cases, it may be necessary to use a grounding jumper to connect multiple metal enclosures together. A grounding jumper is a short length of grounding conductor that is used to bond two or more metal enclosures together. This ensures that all of the enclosures are at the same potential, reducing the risk of electrical shock. Ninthly, it is important to note that some metal switch boxes are designed with internal grounding provisions. These boxes have a pre-drilled and tapped hole for a green grounding screw, as well as a bonding jumper that connects the box to the metal conduit. If using a box with internal grounding provisions, follow the manufacturer's instructions for proper grounding. Tenthly, when working with electrical systems, always prioritize safety. De-energize the circuit before working on any electrical components. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If unsure about any aspect of electrical work, consult with a qualified electrician. 11thly, the importance of proper grounding cannot be overstated. A properly grounded electrical system is essential for protecting people and property from electrical hazard. By following established electrical codes and best practices, and by using the correct hardware such as green grounding screws, it is possible to ensure a safe and reliable electrical installation. 12thly, let's consider some specific scenarios related to grounding metal switch boxes. Imagine a situation where a metal switch box is being installed in a residential setting to control a lighting fixture. The branch circuit supplying power to the switch box is protected by a 15 amp circuit breaker. According to NEC table 250.122 for a 15 amp circuit, the minimum size of the equipment grounding conductor is 14 American wire gauge copper. In this scenario, the electrician would need to connect a 14 American wire gauge copper grounding conductor to the green grounding screw inside the metal switch box. This grounding conductor would then be connected back to the grounding busbar in the electrical panel, providing a low impedance path for fault current. 13thly, consider another scenario where a metal switch box is being installed in a commercial setting to control a motor. The motor is supplied by a 20 amp circuit. According to NEC table 250.122 for a 20 amp circuit, the minimum size of the equipment grounding conductor is 12 American wire gauge copper. In this case, the electrician would need to connect a 12 American wire gauge copper grounding conductor to the green grounding screw inside the metal switch box. Again, this grounding conductor would be connected back to the grounding busbar in the electrical panel. 14thly, another critical aspect is the inspection of grounding connections. Regularly inspect all grounding connections in metal switch boxes to ensure they are secure and free from corrosion. Look for any signs of loose connections, damaged conductors, or corrosion on the grounding screws or connectors. If any issues are found, address them promptly to maintain the integrity of the grounding system. 15thly, regarding older installations, it's possible to encounter metal switch boxes that may not have a dedicated green grounding screw. In such cases, retrofitting a grounding screw is recommended. This typically involves drilling and tapping a hole in the box to accommodate a green grounding screw. Ensure that the hole is properly sized and that the grounding screw is securely tightened. 16thly, it is also worth noting the use of self-grounding devices. Some electrical devices, such as receptacles and switches, are designed with self-grounding features. These devices have a metal clip or strap that makes direct contact with the metal switch box when the device is installed. This provides a grounding path without the need for a separate grounding conductor. However, it is important to ensure that the metal switch box itself is properly grounded to the grounding system. 17th, consider the scenario where a non-metallic sheath cable, also known as Romex, is entering the metal switch box. Romex cable typically contains a bare copper grounding conductor. This grounding conductor must be properly connected to the green grounding screw inside the metal switch box. In this case, a listed cable clamp should be used to secure the Romex cable to the metal switch box, providing mechanical protection for the cable and ensuring that the grounding conductor is properly grounded. 18thly, it's important to be aware of the potential for galvanic corrosion in grounding systems. Galvanic corrosion occurs when two dissimilar metals are in contact with each other in the presence of an electrolyte, such as moisture. This can lead to corrosion of the less noble metal, weakening the grounding connection. To prevent galvanic corrosion, use compatible materials for grounding conductors and connectors. For example, use copper grounding conductors with copper connectors and brass grounding screws. 19th, special attention should be paid to metal switch boxes installed in damp or wet locations. In these environments, corrosion can be a significant concern. Use corrosion-resistant materials for grounding conductors, connectors, and screws. Consider using stainless steel or other corrosion-resistant materials for metal switch boxes in these locations. 20th, grounding is not only essential for safety but also for the proper functioning of electronic equipment. Electronic devices are sensitive to voltage fluctuations and noise on the power line. A properly grounded electrical system can help to reduce voltage fluctuations and noise, improving the performance and reliability of electronic equipment. 21st, it's essential to consult with a qualified electrician or electrical engineer when designing or installing electrical systems. These professionals have the knowledge and experience to ensure that the electrical system is safe, reliable, and compliant with all applicable codes and standards. 22nd, grounding and bonding are closely related concepts, but they are not the same thing. Grounding refers to connecting the electrical system to the earth, providing a low impedance path for fault current. Bonding refers to connecting metal parts of the electrical system together to create an electrically conductive path. Both grounding and bonding are essential for electrical safety. 23rd, a common misconception is that grounding is only necessary for metal enclosures. However, grounding is also required for non-metallic enclosures in certain situations. For example, if a non-metallic enclosure contains electrical equipment that is likely to become energized, the enclosure must be grounded. 24th, in addition to the NEC, other standards and regulations may apply to grounding electrical systems. These may include local built-in codes, industry standards, and manufacturer's instructions. It is important to be familiar with all applicable requirements before working on electrical systems. 25th, when installing grounding conductors, avoid sharp bends or kinks in the wire. Sharp bends can increase the impedance of the grounding conductor, reducing its effectiveness. Use smooth, gradual bends to minimize impedance. 26. Label all grounding conductors clearly to identify their purpose. This can help to prevent confusion and ensure that the grounding system is properly maintained. Use a label maker or other suitable method to create clear and durable labels. 27th. Regular testing of grounding systems is recommended to ensure their effectiveness. Grounding impedance testers can be used to measure the resistance of the grounding path. If the resistance is too high, it indicates a problem with the grounding system that needs to be addressed. 28th. Ensure that all electrical panels are properly grounded. The main grounding electrode conductor should be connected to the grounding busbar in the electrical panel. The grounding electrode conductor provides the connection to the earth. 29th. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, metal water pipes, or concrete encased electrodes. The grounding electrodes are connected to the grounding electrode conductor, which in turn is connected to the grounding busbar in the electrical panel. 30th. When driving ground rods, ensure that they are driven deep enough into the earth to make good contact with the soil. The NEC specifies the minimum depth for ground rods. 31st. When using metal water pipes as grounding electrodes, ensure that the water pipes are electrically continuous and that they are in direct contact with the earth for at least 10 feet. 32nd. Concrete encased electrodes, also known as UFA grounds, are typically installed in the footings or foundation of a building. They consist of a length of bare copper conductor that is encased in concrete. 33rd. It is important to protect grounding conductors from physical damage. Grounding conductors should be routed in a way that minimizes the risk of damage from impact, abrasion, or corrosion. 34th. When working with underground grounding conductors, use direct burial rated conductors. These conductors are designed to withstand the harsh conditions of direct burial, including moisture, chemicals, and physical stress. 35th. Use anti-seize compound on threaded grounding connections to prevent corrosion and ensure a good electrical connection. Anti-seize compound helps to lubricate the threads and prevent them from seizing together. 36. Always follow the manufacturer's instructions when installing grounding equipment. The manufacturer's instructions provide specific guidance on how to install the equipment properly and safely. 37th. Document all grounding system installations, including the location of grounding electrodes, the size and type of grounding conductors, and the results of any grounding tests. This documentation can be helpful for future maintenance and troubleshooting. 38. Grounding systems should be designed to accommodate future expansion of the electrical system. Consider the potential for increased load and the need for additional grounding capacity when designing the grounding system. 39. Proper grounding is not just a matter of following the code. It is also a matter of using good engineering judgment and common sense. Think about the potential hazards and take steps to mitigate them. 40th. Safety is paramount when working with electrical systems. Always energize the circuit before working on any electrical component. Use appropriate personal protective equipment and follow all safety procedures. 41st. Improper grounding can have serious consequences, including electrical shock, fire, and equipment damage. Take grounding seriously and ensure that your electrical system is properly grounded. 42nd. Remember that grounding is a critical component of a safe and reliable electrical system. By following established codes, best practices, and manufacturer's instructions, you can help to ensure that your electrical system is properly grounded and that it protects people and property from electrical hazards. Finally, using a green grounding screw in a metal switch box is not just a code requirement, it's a fundamental safety practice. Adhering to this practice, alongside all other grounding principles, ensures the integrity of the electrical system and the safety of everyone who interacts with it.